In this video, we're going to talk about intercepts and symmetry. So before we actually look at an example problem, let's sketch a couple of graphs real quick, just so we can make sure we understand what we're talking about. So let's say I have this graph. It's a parabola. When we're talking about symmetry, we're saying that if I were to take this side and spin it around over here to this side, so I'm spinning the whole graph around, I end up in the same place. The graph is still there. It is a perfect mirror image of each other. When you have something that is a perfect mirror image across the y-axis, we call this symmetric across the y. Okay, so that's one type of symmetry. Symmetry across the y. If I spin this graph around, I end up with the exact same graph. There's another type of symmetry. So let's say I have this graph right here. And now if I were to spin this graph around the x-axis, if I would take this and I flip it over, I end up in the exact same place. Okay, so when you can revolve it around the x-axis, we call this symmetric across the x-axis. Okay, so there's two types of symmetry right there. Symmetric across the y and symmetric across the x. We have one more. Let's say I'm looking at this graph right here. Okay. If I spin this graph around the x, this ends up down here. Okay. And then if I spin it across the y, it comes back over here. So if I spun it around both axes, the x and the y, I end up with the exact same graph. When this happens, we say it is symmetric across the origin. Okay. So there's three types of symmetry that we're concerned with in college algebra for right now, and it is these three forms. The other thing that we want to talk about in this next example is intercepts. And intercepts are where the graph is crossing an axis. Okay, so here, this one, I have this intercept because my graph crosses the x-axis. Here, it's crossing the y. It looks like it's crossing the x, but it really isn't. It's just touching the x, but it's across the y. We have an intercept through the origin because it's going through the origin. If this was a little bit different, let's say our graph was like this, then we have a y-axis there. So x-axis, x-intercept, through both is origin. Just across the y is the y-intercept. Okay, so here we would be crossing through the x and the y. We can find out all of this information from our equations without having to draw the graph, or we can find all of these points before we draw the graph. Okay, so keeping this in mind, let's look at an example. So here, we want to find the intercepts. If there are any, because it is very possible that your graph doesn't cross an axis, and that's okay. And test for symmetry. Okay. So let's say I have the equation x squared minus y minus 4 equals 0. I don't have to solve this for y. If I'm finding intercepts and testing for symmetry, I can work with my equation exactly as I see it. So let's first find the x-intercepts. When I'm looking for x-intercepts, I want to take y and plug in 0 for y, and then just solve my equation. Okay. So that means here I would have x squared minus 0 minus 4 equals 0, plugging in 0 for y. I can simplify this down, so it is x squared minus 4 equals 0. Now to solve for x, I'm going to add 4 to both sides. This adds up to 0, so I'm looking at x squared equals 4. Now if you've been watching all the other videos, here we can use the square root method. So I'm going to put a square root on both sides. So the square root of x squared equals plus or minus the square root of 4. Okay, so simplifying this, my radical cancels out my exponent. So on the left-hand side, I'm left with x equals, and I know the square root of 4. Square root of 4 is 2, so plus or minus 2. And remember, here you're looking at two different answers, negative 2 and positive 2. An intercept, though, is a point on the graph, so we need an ordered pair. So we have our x values, our y value is 0. So my x-intercepts are the points negative 2, 0, and 2, 0. Okay, that's where we're crossing the x-axis. We also want to look for our y-intercepts. And for our y-intercepts, we want to take x and set that equal to 0. So in my equation, I now have 0 squared minus y minus 4 equals 0. Simplifying this, I get minus y minus 4 equals 0. I want to keep solving for y, so I'm going to add 4 to both sides. These add up to 0. Now I'm looking at negative y equals positive 4. This is not completely solved yet because I don't have y by itself. I'm going to divide both sides by negative 1 to get rid of it. And I'm left with y equals negative 4. Okay, but remember, I'm looking for an intercept, and an intercept is a point, so that means I need an ordered pair. So my y-intercept my x value here is 0, and we found my y value to be negative 4, so the y-intercept is 0 and negative 4. So I found all the points where my graph is crossing the axes. The next thing I want to do is test for symmetry. Okay, so let's get a fresh sheet because I need the room. So symmetry tests. For my x-axis symmetry, I want to take y and substitute in negative y. Okay, Okay, that sounds a little odd, so let's look at it. My equation, remember, is x squared minus y minus 4 equals 0. So to plug in a negative y for y, I'm going to have x squared minus, in parentheses, minus y minus 4 equals 0. I'm going to keep simplifying. So double negative property tells me that this is really addition. So I'm looking at x squared plus y minus 4 equals 0. I have nothing else to do here. I'm not being asked to solve for either one of my variables. I'm being asked to test for symmetry. Replacing this y in and simplifying, now I see that I have a completely different equation. So it looks very similar, but this is negative y, this is positive y, so my equations are not equal. So it is not symmetric. Across the x. Okay. So all we're doing is plugging in a negative variable, we're simplifying it down, and we're seeing if we get the exact same equation back. So for y-axis, when I was testing for x-axis symmetry, I was working with my y values. And so for my y-axis, I want x, and I want to substitute in negative x. Okay. So remember, my original equation is x squared minus y minus 4 equals 0. I'm plugging in a negative x for x. I'm going to do that in parentheses. Negative x squared minus y minus 4 equals 0. So remember that this right here really means negative x times negative x, and negative x times negative x is positive x squared. So when I simplify, I have x squared minus y minus 4 equals 0. So I'm done with my simplifying. I'm not solving for anything else. So I just need to compare my equations. So I have x squared minus y minus 4, and I started off with x squared minus y minus 4. So my equations are equal. They're the same. So we say this is symmetric across the x-axis. Okay. So just keep in mind, this right here, not symmetric across the x, and symmetric, I'm sorry, this is symmetric across the y-axis. I was working for y-axis. And this, symmetric across the y-axis. These are your answers. They asked you about symmetry, so you need to write a statement saying whether or not it is symmetric. Okay, it's not enough to just show the work. This is telling the instructor you understood your results. Okay. We have one more test for symmetry. We talked about 3 kinds, and the last test for symmetry is symmetric across the origin. So origin symmetry. So if I'm symmetric across the origin, I'm going to take x and substitute in negative x, and I'm going to take y and substitute in negative y. I just did both of these things, but now I'm going to do both of them at the same time. So my original equation is x squared minus y minus 4 equals 0. And I need to make these replacements, so I'll do it in blue so we can see them. Okay, so there are my two replacements. And I need to simplify. So we saw earlier that negative x squared is going to give me positive x squared. We know that double negative property means I'm looking at addition here. And I still have minus 4 equals 0. And again, now that I finished simplifying, I'm just comparing my equation to my original equation. And I can see once again that they are not the same thing. The difference is here. This is minus y, this is plus y. So equations are not equal. So it is not symmetric across the origin. Now, this question didn't ask us to graph anything, so we found our intercepts. Negative 2 and 0, 2 and 0. 0 and negative 4 is my y-intercept. And then we did our 3 symmetry tests. We found that it was not symmetric across the x. It is symmetric across the y, but it was not symmetric across the origin. And we're done.